Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about repeated trials and what I'm going to call best of N series in this case. So, little bit of inspiration. Back in March, we did a picking the perfect bracket Thursday Tidbit set, and we explored predictions in the NCAA men's basketball tournament. Now, this tournament what was called a one and done tournament. So this means that teams played individual games against each other to determine who advanced, who made it on, or won the tournament that way. So when teams played, they played a single game with the winner going on. Now, a little bit later, we're now into NBA and NHL, so basketball, hockey playoffs. Now, traditionally, these professional leagues play what are called these best of series. So these playoffs mostly take place with best of 7 series there. Now, what this means is that they play up to 7 games. We'll talk more about that in a second. And the first team to win 4 games advances or wins in that case. So this is where that best of 7, right? 4 out of 7 is more than half. So if you win more than half of the games, so 4 in total, you are crowned the total winner of that series in that scenario. So our big question of the day kind of is, how does this affect the probability of winning there? So let's start to explore this and look at a couple of examples. So we're going to be dealing with 2 teams, Team A and Team B. So for now at least, Team A we're going to assume has a 60% chance of winning against Team B. Now, this means, right, of course, if they play that one game, that one and done game, Team A has a 60% chance of winning, advancing in that case. So now we want to explore then, well, what happens if they play one of these series? And just to set some stuff up, let's start with a best of 3 series in this case. Now, remember that probability of Team A winning, right? This is going to be 60% for a single game. So 60% or 0.6, that is the probability that they win a single game in this series. Now, we're going to talk about this a little bit more in the next slide too. But one of the things we have to be a little careful about is this best of business. Right? So one thing that could happen, and in real life then, if this happens, right, if A wins the first 2 games, the whole series is over, right? This makes sense. Why would you make 2 professional teams play a 3rd game where the outcome of that game doesn't matter at all, right? So in this case, we would just stop. We have 2 games. A wins both. They now win this series. So this has a 0.6 times 0.6. So this is a 0.6 squared in this scenario. So here we have 0.6 squared in this case there. Now, if it takes 3 games, now this is something we're going to actually show how to skip over a little bit, but we need to be a little careful with 3 games, because if it takes 3 games, that means that A must win the final game, right? We can kind of group them together that way, and then that means B must win one of the first 2 games. So we could have, in a sense, 2 scenarios here. We could have BAA or ABA in that scenario. Now, when we write these out here, right, these are going to be very similar. So B has a 0.4% or 0.4 chance of winning. Then we would have 2 0.6s in this case. And the other one is just moving around the 0.6s and the 0.4, alternating those a little bit. Now, because of that, and we're going to see this more in the future too, we typically combine these. And so we could say there's two ways for this to happen. And then both of those ways have the same 0.6 squared times 0.4 chance in that case. And so the reason for that is that we can then start simplifying our calculations and try to look for patterns. And you can find the patterns, you can look at this in general that way too. So we start thinking about a total from here, however, right? We have our 0.6 squared chance here. We have our 2 times 0.6 squared times 0.4. We add those up, and our total in this case, right? Let's skip a little bit of the calculations. If you get the total answer here, you will have 64.8% in that scenario. So just want to point out a little bit that this is a 4.8% increase from before, almost 5% increase in this case. So by playing the best of 3 series, the better team has a higher chance of prevailing. Now this shouldn't surprise us because the more games they play, in the sense, less is going to random chance, right? So if A has a 60% chance of winning, the more times you actually play, more often than not, they're going to win. And so on average, they're winning more of the games. And so let's see here, before we do a best of 7 or something, let's see if there's any way we could simplify this a little bit as well. Now, calculations are still a little bit messy, but this is my preferred way of dealing with a series like this. So to remind us of what we had before, we had this AA, and then we had our two ABA and BAA. So I know I flipped the order around a little bit here, but that doesn't really matter there. Now, I said in practice, in the real world, in that first scenario, we would never play those first 2 games, right? These 2 games would never actually be played in the real world scenario. Now, if we wanted to say, well, what happens if they were played? Well, this could actually split into 2 scenarios then, right? Well, maybe A wins the final game as well, or maybe B wins the final game in that case there, right? And that doesn't affect the final outcome, because in all of the scenarios then A has won more games than B, so they would be determined as the final winner there. Now, if we look at it this way, however, this is going to give us a strategy we can use moving forward. So what is this first scenario here? This first scenario is them winning 3 games, right? So this one here is 0.6 cubed in this case. And actually, let me just write it as there's one case here. There's one way that A could win all 3 games, and then we have 0.6 for them winning each of those games there. Now, other scenario, notice if we group all 3 of these together, they all have them winning exactly 2 games. Here there's 3 ways this can happen, and then if we multiply this out, we have a 0.6 squared for those 2 games they're winning, and a 0.4 to the first power for that 1 game we're winning there. So the key takeaway here is that when we play this best of 3 series, the equivalent way you can think about this is kind of, if you like, an if and only if statement, right? That A needs to win at least 2 games. And so you can think of it as they play all 3 games and A either wins 2 of them or 3 of them in that scenario. Now, why is this helpful? Well, this is something that has actually a pretty nice pattern in general. So we've covered this in Thursday Tidbits last year a little bit, but right, we can actually use binomial coefficients and the kind of binomial theorem in a sense, or binomial distribution. It's not quite the binomial theorem, but in our case, it will help us out here. So suppose a team has a P chance of winning, then they play N games, and we want to know the probability that they win exactly K of those games. And this can actually be done, right, kind of either binomial theorem, binomial distribution, whatever you want to call it here. So the components, we have n choose k. So remember, this is n factorial divided by k factorial times n minus k factorial. And this, remember, is deciding which games they win, right? In a sense, this is the number of cases we have to kind of deal with for each scenario. So, okay, if they win 2 games, is it the first 2, the first and the last, the second and the third, blah, 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 right? This is the number of cases or the number of ways that it can happen there. And then, of course, the actual probabilities are done here, right? So the P chance is, so this is the probabilities. So those K games you chose the first team to win, the probability they actually win the first and second or first and last game is, right, P raised to however many games there are. So P is winning, the first team is winning K games, the other team is winning N minus K games, and then the N choose K is how many cases, how many arrangements we can think of in that scenario. Now, because of that switch then, this is going to be very helpful for doing our calculation here. So now we're ready, right? We're going to skip the actual calculation at the end. But what is Team A's chance of winning against Team B if they play that best of 7 series, like is typically done in the NBA or the NHL, things like that there. Now, remember that this is equivalent to, the way we want to think about best of 7 series means that they win at least 4 games. So that is what we have here. And the reason that we did that previous formula is that previous formula helps us out a lot here, right? Remember, Team A had a probability of 0.6 of winning. And now we can literally start plugging stuff in there. Team A could win exactly 4 games, pretending they played all 7. The probability they win those games is 0.6 to the 4th. The probability they lose the other 3 games is 0.4 to the cubed there. And now these, right, I'm going to write them all out, but they're all pretty much exactly the same. We have 0.6 raised to the how many games they win, 0.4 raised to the how many games they lose. And so then we're really thinking, okay, how many ways can it happen? And then we multiply by the probability each time there. And right, just to help us notice the patterns, I'm going to write all of these out with the exponents, just so we can see there that we always have these changing exponents in that case. So I know I don't need 0.4 to the 0th power, but that kind of helps us see the pattern that way there. Now, if you do this calculation, shouldn't surprise you that it's bigger than 60%, shouldn't surprise you that it's bigger than 64.8%. It's actually 71.0208% there. So more games, less random chance in a sense, and so this probability of A winning is increasing in that case. So there's, in a sense, less randomness when we do these best of series in that case there. So let's talk about one real world advantage, and that is home court advantage here. So these playoff games we're looking at typically are played in one of the team's arenas. So, right, you might play in Team A arenas one game, Team B arena the next game, that way there. And typically, this is something that actually gives more of an advantage to the better team. So, right, why might this matter is that traditionally teams play better at home, in their home arena. So, Team A playing in Arena A versus, right, on the road where Team A would be playing in Team B's arena there. So, how could we look at this in terms of our question of the week? Well, so let's assume that these percentages change by 10%. So Team A, remember, started as a 60%. So I want you to think of this as they have a higher percentage, 10% better chance of winning at home. So instead of 60%, it's 70%. They have a 10% worse chance of winning on the road. So instead of 60%, it's 50% chance there. Now, question, where are the games played? So assume that this is played according to the following schedule. So this is how things like the NBA do this there. So games 1 and 2 are played in Team A's arena. 3 and 4 are Team B's arena. 5, 6, and 7, if those are necessary, alternate ABA there. So that's the way that these arenas are chosen as far as the schedule here. So the question at this point is pretty natural. So this is the one I want you to think about this week, and we'll take more and look more at it next time. Under these assumptions, so the home versus away probabilities, how does this affect that best of 7 series? Does this help A more, help B, not really make too much of a difference? Try to look at those calculations, which are a little bit messier. Now that we have to take into account home versus away, that is something we have to look at. And as you're doing that, you don't need to do calculations, but feel free to if you want to. What other factors might come into play? Are there ways we could incorporate those into our calculations if we're trying to make predictions or things like that from there? So, thanks everyone for watching. Stay tuned for the continuation where we talk more about that problem, home versus away, and how it affects things next week. And if you have ideas for future videos, please let us know in the comments below. Even if you don't comment, like, subscribe really helps. But otherwise, I will see everyone next time. Goodbye.